Hello and welcome to the first in a line of tutorial videos going through the mock papers. My name is Mr. Scott, and in this video we're going to have a look at the first half of the first paper. This paper is specifically for the new spec. You'll notice it's got levels 9 to 1 on the front, and it is a non-calculator paper. So in this paper I am going to be talking a little bit through how I mentally go through some of the arithmetic. I recommend you have your paper with you. Get yourself a different coloured pen. Go through it with me and you'll find it easier to remember some of the methods. I'm also going to try and show you where the marks come from. There's a little mark counter in the bottom corner throughout the video. There are a lot of different ways of getting the marks. You don't have to do it the exact way I have. You'll also notice that I'm writing down quite a lot, trying to explain how I'm doing it, so you don't necessarily need all of what I'm writing down to get the marks either. If you want to know exactly how to get the marks, I recommend you ask your teacher for the mark scheme yourself and you can have a look. Mark schemes are quite complicated, but it is a good idea to have a look through, particularly if you're doing the higher paper, to understand how the examiners are giving away their marks. There'll probably be some questions in here that you've got 100% in and you want to skip through. This video is probably a little long to be accurate enough to just skip through by clicking on the scrub bar on the bottom on YouTube. You may want to use the left and right keys on your keyboard. That's a nice way on YouTube to skip through. It uses 5-second gaps. If you are just looking for a specific question, if you look in the video description down the bottom, you might need to click show more. You'll see a list of all the questions with hyperlinks that will take you straight to that question. So, without further ado, let's get started. Okay, welcome to question 1. For question 1, first thing to note is each of the 3 parts is worth only 1 mark. That means we're not going to have to write any working down. We're just going to write the answers. For part A, we have to factorize. So we're going to write it as 2 things multiplied together. Y squared plus 27y. So to do this we're going to find a common factor. We can find a y in the first term and the second term. So we're going to take out y. That gives us y in the first term and 27 in the second term. If we multiplied this out we would get y times y, y squared, and the y times 27 plus 27y. So that's your answer. Y plus 27. For part B, we're going to simplify, and part C is a simplify as well, so we're just going to write it in simpler terms. T cubed is t times t times t, and we're looking for t cubed all squared, so that's that times by itself. Well, that's just going to be, instead of having the squared, that's just going to be times by t times t times t. So that's t times by itself 6 times t to the power 6. Part C, w to the power 9 divided by w to the power 4. W to the power 9 is w times w times w times w times w and so on, divided by w times w times w times w. So 9 w's all times together on the top, divided by 4 on the bottom. When you divide by w, you're basically just cancelling out one of the w's you've multiplied. So we can take one off the bottom and one off the top, and so on. If we had 9 w's all times together on the top, divided by 4 w's, that will get rid of 4 of them, giving us w to the power of 5. Now, you don't need to go through any of the working like I said. Hopefully you know your indice rules. For part B, some power to another power, multiply the powers. If you're doing a division of powers, you can subtract the powers. And that's question 1. Okay, question 2. The diagram shows a square, that is important, with a perimeter 16 centimeters. Work out the proportion of the area inside the square that is shaded. So firstly, it's important to realize it is a square. That means that it has a side length of 4. Because 4 times 4 is 16. We have to work out the proportion of the area inside the square that is shaded. So we can give that answer as a fraction. What fraction of the square is shaded? Well, to find that out, we need to find out what is the area of the shaded region. The easiest way to do that is to find triangle A and B, and then take that away from the whole square. As the sides are length 4, triangle A is going to have a side length there of 1 and 4. B is going to have 2, and it's going to have a side length of 4 there. So to find those areas, the area of A, that's got a side length of 1 and 4, so we're going to do the area of a triangle, which is height times width divided by 2. That's giving us 4 divided by 2, which is 2. And the area of B, height times width, 4 times 2 divided by 2. That's 8 divided by 2, which is 4. So, area of shaded is going to equal area of the whole square. This is the square of 4 by 4, so 4 times 4. Take away the area of A, which is 2, and take away the area of B, which is 4. 16 minus 6 equals 10. So the area of the shaded region is 10. If we want to find the proportion of the area inside the square that's shaded, that is going to be the area of the shaded region out of the area of the whole region. Okay, question 3. It's quite a complicated probability question, this one. There's quite a lot to it. David's designed a game. He uses a 6-sided dice and a 5-sided spinner. Each player rolls the dice once, spins the spinner once, and a player can win £5 or £2. He expects 30 people to play his game. Each person pays £1 to play, and we need to figure out how much he's expected to make. How much profit is he expected to make? So first let's have a look at winning £5. This is the easier one. To win £5 you have to roll a 5 and spin a 5. So to find the probability that they win £5, we need to multiply the two together. So the probability they roll a 5, 1/6, multiplied by spinning a 5, 1/5. So to multiply fractions, we multiply the numerators, 1 times 1, and we multiply the denominators, 1/30. So 1 in 30, we're expecting someone to win £5. We'll come back to that later. Winning £2 is a little bit more complicated. A lot of people make the same mistake in this part and think that if you roll a 1 or spin a 1, you can just ignore the both and just add the probability of rolling a 1 to the probability of spinning a 1. It doesn't quite work. It's a little bit more complicated than that. Let's have a look why. First, let's use a probability tree diagram to show all the different things that could happen. First we're going to roll, then let's spin. If you roll a 1 or don't roll a 1, and then you can either spin a 1 or don't spin a 1, spin a 1 or don't spin a 1. So to win £2 we're looking at these 3 scenarios. You either roll a 1 and don't spin a 1, you don't roll a 1 but do spin a 1, or you roll a 1 and spin a 1. You do both. We just want the probability that you roll a 1, 1/6, multiplied by the probability that you spin a 1, 1/5, that's 1/30. Or we could roll a 1 and not spin a 1, that's 1/6, multiplied by 4/5, so that's 4/30. Or we don't roll a 1, 5 out of 6, but you do spin a 1, that's 1/5, giving you 5/30. Those 3 totaled, 1/30 plus 4/30 plus 5/30 give you 10/30. So 10 out of 30 is the number of times we're expecting someone to win £2. So how much profit can David expect to make? Well, he expects 30 people to play. Each person's going to pay £1, so he's going to make £30 there. But he's going to lose the money that people win. 1 out of the 30 people are expected to win £5, so we're going to lose £5. And 10 out of the 30 people are expected to win £2, so we're going to lose 10 lots of 2, £20 there. 30 take away 5, take away 20 is going to leave him with £5 profit. Part B, give a reason why David's actual profit may be different to the profit he expects to make. Lots of different answers here you could do, but the one that kind of covers everything is just that probability is likelihood, not certainty. And that would cover it. There's a few different things. You could be a bit more specific and say something like he expected 30 people to play, but maybe more played, maybe less did, something like that. Question 4. Triangle ABC has perimeter 20 centimeters. AB has size 7 and BC has size 4. By calculation, so that means we're going to have to actually use a calculation. We can't just draw it and measure it. Deduce whether the triangle ABC is a right angled triangle. As soon as we're seeing the words right angled triangle, we're immediately thinking Pythagoras. So first let's think about this triangle. We've got one side of 7 and one side of 4. That totals 11. It has a perimeter of 20, so that means our other side is going to be 9 centimeters. So the side AC is going to be 9 centimeters. 9 centimeters is larger than 4 and 7, so that means it's going to be the hypotenuse. So if it is a right angled triangle, we're expecting something like this: a 4-sided 7 and a 9 centimeter side there. If it was a right angled triangle, that would mean that the Pythagoras theorem would work. Pythagoras theorem is a squared plus b squared equals c squared, so the hypotenuse squared. So let's have a look if this works. So let's first look at the left hand side. A squared plus b squared, well, if we label our sides a, b and c, a squared is going to be 4 squared plus b squared, which is 7 squared. That equals 16 plus 49, which equals 65. For the right hand side, we've got 9 squared, which is 81. Now 65 does not equal 81. So we can't just stop there to get all the marks. We do actually need to add a little bit more. We've said that 65 doesn't equal 81, but we haven't actually shown the examiner we know what that means. We might have just got there and given up. We need to really make it clear that we're aware this means it isn't a right angled triangle, so we would just write at the end here, not a right angled triangle. There we go. Okay, question 5. One sheet of A3 card has an area 1/8 meters squared, and the card has a mass of 160 grams per meter squared. So every meter squared of card, it weighs 160 grams. Work out the total mass of 25 sheets. So if every sheet of A3 card has an area 1/8 meters squared, and the card has a mass of 160 grams per meter squared, that means that each individual sheet is an eighth of 160 grams. So to figure that out, we're going to have a look at 160 grams divided by 8, an eighth of 160. A nice way of dividing by 8 is to half it, half it, and half it. Half it 3 times. Half of 160 is 80. Half of 80 is 40. Half of 40, 20. So each sheet weighs 20 grams. How many do 25 sheets weigh? We need to do 25 times 20. Same as 25 times 2 times 10. Maybe an easy way of doing it. 25 times 2 is 50. Times by 10, 500 grams. Moving on to question 6. Work out 2 1/4 times 3 1/3. Give your answer as a mixed number in its simplest form. Okay, so this is standard stuff. Make sure you know all the rules about multiplying, adding and dividing fractions before you go into the exam. In this one we've got 2 1/4. So that's 2 wholes and a quarter. There's 4 quarters in a whole, so in 2 wholes there's 8 quarters. So 2 wholes and a quarter is 9 quarters. We're multiplying that by 3 1/3. There are 9 thirds in 3 wholes, plus the other third gives you 10 thirds. Our rule for multiplying fractions together: multiply the denominators and the numerators together. So 9 times 10, 90, 4 times 3, 12. So to cancel this down, 90 and 12, well, they're in a few different times tables, but they're both in the 3. So we can go 30 over 4, and 30 and 4, we can half both of those to give us 15 over 2. Our answer here is in its simplest form, but it's not a mixed number. 15 over 2, that's the same as 15 halves. So that's the same as 7 and 1/2. And that's your answer. And part B. Write the numbers 3, 4, 5 and 6 in the boxes to give the greatest possible total. We're going to write each number once. We've got boxes for the whole numbers and we've got boxes for the denominator of the fractions. So if we want the biggest total, it makes sense that we put the biggest whole numbers in first. Fractions are going to count for less. So the biggest numbers are 5 and 6, so we'd write in 5 and 6. Doesn't actually matter which way around those goes, it's still going to be 5 plus 6. The next part's a little bit trickier. We've got a 3 and a 4 left. We need to figure out, is a third plus 2/4 bigger, or is a quarter to 2/3 bigger? Well, let's have a look. When we add fractions, we need to make a common denominator. Easiest common denominator to make here is 12, so we're going to multiply the third top and bottom by 4, giving us 4/12. And for the 2/4, we're going to multiply top and bottom by 3, 6/12. Adds together to make 10/12. On this side, we've got a quarter, which we're going to multiply top and bottom by 3 to make 3/12, and 2/3 top and bottom by 4, 8/12, giving us 11/12. So actually this side's bigger, so we're going to put in a 4 and a 3. Question 7. Very standard, classic GCSE Maths exam question. Microwave ovens are a third off. Combination ovens are 40% off. The microwave oven has a sale price of £90. The combination oven has a sale price of £84. Which one had the greater normal price? So these are the sale prices, so the third has already been taken off and the 40% has already been taken off. So let's look at the microwave oven first. If a third has been taken off, that means that 2/3 are left. So 2/3 is £90. That means that a third of the price would be half of 90, which is £45. So the full price, which would be 3/3, is 3 lots of 45, which is £135. That's the microwave oven. Let's have a look at the combination oven. So the combination oven is 40% off, that's leaving 60%. So 60% is £84. We want to find out what 100% is, so a nice step would be to find out what 10% is. 10% would be 84 divided by 6, which is £14. So 100% is £140. So looking at those two prices, it's quite clear that the combination oven was the more expensive, had the greater normal price. We need to clearly show that we know this. It's not enough just to go through the workings, so we would just end it with a nice simple sentence and just say that. So it's not enough just to write down those numbers, we need to actually give an answer right at the end. So our answer is that the combination oven cost more originally. Alright, question 8. Work out an estimate for the square root of 4.98 plus 2.16 times 7.35. We're looking for an estimate here, which means looking at them, the most obvious way of estimating these is going to be to go square root 4.98, that's 5, plus 2.16, that's 2, times by 7.35, 7. Those easy estimates. When we're solving this, we need to remember that BIDMAS applies, which means our multiplication is going to come before our adding. So we're going to be doing our 2 times 7 first, and adding the 5 to that. So 2 times 7 is 14, plus 5 is the square root of 19. So now we need to come up with an answer for the square root of 19. 19 isn't a square number, so it's not going to be a whole number answer. So let's think about our square numbers. We've got the square root of 16 would give us 4. 4 squared is 16. And the square root of 25 would give us 5. So square root of 19 is going to lie somewhere in the middle here. It's going to be somewhere between 4 and 5. 19 is closer to 16 than 25, so it is going to be closer to 4. So maybe something like 4.3. The mark scheme gives you a mark if you had anywhere between 4 and 4.5. So as long as you put an answer there, you're absolutely fine. Okay, so question 9. We've got a cuboid. We know that all the measurements are in centimeters. X is an integer, so it's a whole number. And we've got a height of x, a width of 3 lots of x, and a depth of 2 lots of x. We're told that the total volume of the cuboid is less than 900 centimeters cubed. And we need to show that x, therefore, is less than or equal to 5. So we're looking for some algebra here, and we're looking for the total volume. So algebraically, the volume of this cuboid is the height times the width times the depth. So we've got x multiplied by 3x multiplied by 2x. And we're told that is less than 900. So if we multiply those together, x times x times x will give us x cubed, and the 3 and the 2 multiplied together give us 6. So we've got 6x cubed is less than 900. And let's rearrange this algebra. Let's divide by 6. So x cubed is now going to be less than 900 divided by 6. Not the easiest. We could divide by 3 to get 200, then divide by 2. Or you might be happy just saying that dividing by 6 is 150. So we've got x cubed is less than 150. What values of x, if we know they're integers, will give us an answer that is less than 150? Well, it's a show that question, so we can already see from the question that our answer is going to be 5. But because it's a show that, we need to show that ourselves. So how can we show it? Well, we could just test some numbers. Let's chuck in 5. So if x was 5, 5 cubed is, that's 125. And if x was equal to 6, we'd have 6 cubed, which is 6 times 6 is 36. 36 times 6, we could work that out on paper, or you might be happy knowing that's 216. So looking at those, 216 is too much, 125 is fine. So that means if we had an integer value cubed that is less than 150, the biggest that could be is 5. So x is less than or equal to 5. Alright, question 10. So y is inversely proportional to x. So inversely proportional means that y is proportional to 1 over x. It's proportional to the reciprocal of x. If it's proportional to 1 over x, that means that y will be equal to some multiple of 1 over x. So let's use the values we've been given. We've been told that when x is 1.5, y equals 36. So we can plug those in and see what this constant of proportionality is. So y is 36. We've still got our k, and x is 1.5. To figure out what k is, we simply multiply both sides by 1.5. So we get 36 multiplied by 1.5. And that tells us that k is going to be 36 times 1.5, 1.5, 36 is going to be 54. So we know what k is. Now we can plug in our value of x to find out what the value of y is. So using our k equals 54, we're going to plug it in. So y is equal to k over x. Y is equal to 54 over x. X is 6, so y is going to be equal to 54 divided by 6. 54 divided by 6 is 9, so y equals 9. Okay, question 11. You need to be pretty hot at your manipulating algebra for this question. There's a lot of it in there. They've given you some equations to use. It's also quite a tricky question just to know what to do. Reading through, we've got a solid. It's made up with a hemisphere and a cone. We've got another solid. We've got a cylinder. And they tell you, this is the big clue, the cylinder has the same volume as the solid. So as soon as you see something like that saying it's got the same volume, same surface area, something like that, you know that you can make an algebraic equation because they're the same. So you can just find the volume of one of them and then make it equal to the volume of the other. We'll kick it off by finding the volume of this shape, the solid. Now we've got a hemisphere, so we're going to use the volume of the sphere, and we're going to use the volume of the cone to find this. So let's have a look at it. First thing to notice is that the cone and the hemisphere are all together for the height. We've got 5x for both. Because it is a sphere, that height there is going to be x as well. So we could split this into two. We could split it there and there. Instead now we've got a small x there and 4x there. So let's do the volume of the hemisphere first. Volume of the sphere they're given over here is 4/3 pi r cubed. So the volume of this hemisphere is going to be 4/3 pi r cubed. The radius is x, so we're going to write x cubed. And that's the volume of a sphere. We want half of that for the hemisphere, so we can multiply that by a half. For the volume of the cone, we've got the formula for it, 1/3 pi r squared h. This is going to be 1/3 pi, the radius is still x, so x squared, and the h, we're going to multiply that by the height, which is 4x. Taking these two together, the volume of that altogether is going to be this one. Now a half times 4/3 is just going to be 2/3. So we're going to have 2/3 pi x cubed plus the volume of the cone, that's 1/3 pi x squared times by 4x. The third times by 4 is going to give us 4/3. And we've got pi x squared times x cubed. 2/3 pi x cubed plus 4/3 pi x cubed. Altogether, that gives us 6/3 pi x cubed, which is just the same as 2 pi x cubed. Alright, let's have a look at the volume of this cylinder. Volume of the cylinder, that's just a prism, so we're going to look for the area of that face, multiply it by its height. Face is just a circle, so we're going to have pi r squared, radius being 2x, pi r squared will look like that, and we're going to have to multiply that by its height, h. This is going to equal pi times 2x squared. 2x times 2x is going to be 4x squared, times by the height. Written neatly, put the number at the front, 4 pi x squared h. So we've got the volumes of our two shapes. The question tells us that they have the same volume, so we can make those equal to each other, and the end result is that we want a formula for h in terms of x. So we're going to rearrange it and put h at the front. Got our two volumes, 2 pi x cubed, 4 pi x squared h. We've told the volumes are the same, so we can write down 4 pi x squared h is equal to 2 pi x cubed. I want to rearrange the formula to make h a subject, so I want h equals, and then in terms of x, everything else in x. So that's nice and simple. This is 4 pi x squared times h. So if I want h by itself, I'm just going to divide by all of this. So h equals 2 pi x cubed, all divided by 4 pi x squared. Now the question wants it in its simplest form. There's a lot that can cancel down here. We can cancel down the pi's, they're going to disappear altogether. X cubed divided by x squared, so that's going to cancel the 2 on the bottom, and all the 3 are going to go. And 2 divided by 4 is the same as a half. So we've got h equals a half. Pi's are gone, so we're just left with x, a half x. Whew, what a question. Well, that's the end of the first half of the paper. Hope you guys are still awake. Stay tuned, keep an eye on this channel, and the other halves of the papers will turn up very shortly. Here's a little teaser. Parallelograms.